Welcome back again, ladies and gentlemen. We're on to lesson 3 of this chapter on proportions and ratios. We're going to talk about identifying proportional and non-proportional relationships in a table. A table has an x and y column. If you recall, y is the dependent variable. So in this case, we need to figure out which depends on which. So the amount of pay you get depends on the amount of hours worked. So this would be x, and this is y. Y is always the one that's dependent on the other. You're hired by your neighbors to babysit their children Friday night. You're paid $5 per hour. Complete the table relating your pay to the number of hours you worked. So if I work 1 hour, I get $5. This is my unit rate. 2 hours would be $10, and so on. So I'm multiplying each one by 5. This one is 20 to 50. 5 times 5 is 25, and we continue on down 30 to 50. Is pay proportional to hours worked? How do you know? There's a couple things you need to look for. Are the ratios equivalent? That's yes. So I have 5 to 1, 10 over 2, 15 over 3. They will all reduce to the unit rate of 5 over 1. And also, 0, 0 needs to be a part of this table also. So if I don't work any hours, I don't get paid any money, so that is true too. So that means this is proportional. So yes, it's proportional. All the ratios are equivalent. So that's how we determine if something is proportional to something else. For number 2 through 4, determine if x is proportional to y. Justify your answer. So this case, table below represents the amount of snowfall in 5 counties. 10 over 2 would be my ratio for the first one, that's 5. 12 over 6, that's 2. So automatically I know that it's not proportional because they're not all equivalent ratios. So this is a no, not the same unit rate, we could say, which is what we found, 5 and 1, or not equivalent ratios. Number 3, the table below shows a relationship between cost of renting a movie to the number of days on rent. So cost is $2 for 6 days. That's 1/3. $3 for 9 days. That's 1/3. 8 for 24. That's 1/3. And 1 for 3. That's 1/3. So this is yes. Same unit rate. Or I could say they're all equivalent ratios. Number 4, the table shows a relationship between the amount of candy bought and the total cost. So I'm going to leave number 4 for you to try. See if you can come up with whether or not it's proportional and why. Randy is planning to drive from New Jersey to Florida. Randy recorded the distance traveled, the number of gallons used every time he stopped for gas. Assume the miles driven is proportional to gallons consumed. So they're telling us it's proportional. Complete the table. So from 2 gallons to 4 gallons, I doubled how much I consumed. That means if it's proportional, the miles driven must also double. So this would be 108. 4 gallons consumed, double that is 8 gallons. So I'm going to take this total, and notice it works. Okay. So now the easiest way to do this is if I find the unit rate, I can fill in the rest of these blocks pretty easy. So the miles driven depends on how many gallons of gas I use. So the miles depends on the gallons. So 54 miles over 2 gallons. My unit rate would be 27 miles per gallon. So if I want 10 gallons, I take 27 times 10 That's 270. For 12 gallons, I take 27, my unit rate, times 12. That gives me 324. Now if I have the miles driven, I know it's 27 miles per gallon, so I take 189 divided by 27 now, and that's going to give me 7 gallons consumed. So once I find the unit rate, I can use that different ways to figure out parts that are missing. And we're going to work more about that during class. Keep in mind that all of these have an equation that you could use, and we'll talk more about that also. If you have any questions, bring those to class, and then we're going to discuss a few things in class.